Okay, so let's start our quiz review. Did everyone pick up the new calendar? And the quiz review.
So the quiz would be like, would it be like one of each problem?
Yes. So I'll kind of highlight what we can expect on the quiz.
And the next test is on my birthday. It always happens every year.
Officer.
Yeah. Last year there was one like that, so not this class, but a different class.
Yes. Okay. So I'll circle the problems that we definitely going to see one of. So there's definitely going to be a linear approximation problem. So we'll definitely and I'll put up on the board in the class what we can expect in terms of what type. We're going to see L'Hopital's rule problem. Number 1 is Pythagorean theorem. Number 4 is a volume. I want to go after what you're going to see for sure. You're going to see a cone problem for sure. And then from there, you'll just see a variety of different types. It could be a shadow problem. It could be a cylinder. It could be spheres. But you'll probably get either, I'm looking at maybe 3 or 4 related race problems, and then 1 linear approximation and 1 L'Hopital's rule.
There's gonna be any like multi-part related race ones. Just gonna be...
Yeah, some problems may be connected, like number 6, where you have a Pythagorean theorem followed by an area of a triangle. So those are usually go hand in hand. But yeah, we'll just get through as much as we can today, and then yeah, and I'll have help sessions Monday morning, Monday afternoon, and Tuesday morning. So any ones that I don't go through in class, I can definitely spend those help sessions going over. Okay. I attached all the keys for all the problems, so hopefully you guys have some time this weekend to practice some more problems. Okay. All right, balloon is rising vertically above a level straight road at a constant rate of 1 foot per second. The bicycle is moving at a constant rate of 17 feet per second, and it's going to pass under it, under the balloon. How fast is the distance between the bicycle and the balloon increasing 3 seconds later? So what category of problem is this?
Shadow.
Yeah, not a shadow problem, Pythagorean theorem problem. Okay, so you got the length, the distance from the starting point to where the bicycle is, the distance from the starting point to where the balloon is, and then also the distance between the two of them, which is the hypotenuse. Okay, so I'll call this the X. I'll call this the Y. I'll call this the Z. Do we have any constants in this problem? Are any of those staying put the entire
The
problem?
rate of 1 p per second.
Yeah, the rate is constant, but is the distance of X, Y, and Z staying constant? There's always, it will keep increasing, right? Bicycle will keep moving further away, the balloon will keep moving up, and the Z will continually change. Okay, so Pythagorean theorem, right? We find our derivative. Every variable gets a time variable at d over dt. Okay, let's list out all the variables. All right, so let's gather all the information. Let's start at the very beginning. A balloon is rising vertically at a constant rate of 1 feet per second, 1 foot per second. What's that we're describing? dy dt, positive or negative? Positive, because it's increasing. Not necessarily because it's going up, it's that distance is increasing for y. Okay, good. Just when the balloon is 65 feet above the ground. Y, okay. Now I'm going to put 65 here. We may have to revisit this, but we'll put that there for now. Okay. A bicycle is moving at a constant rate of 17 feet per second. Dx dt. Positive or negative? Positive, right? It's gonna, that distance is increasing as he gets away from the balloon. How fast is the distance between the bicycle and the balloon increasing?
dz
dt. 3 seconds later. Okay, so this, we have to make some adjustment because we want to figure out 3 seconds after the bicycle passes under the balloon. So imagine you're standing far away and 3 seconds later, you take a snapshot. 3 seconds later, what's going to be that moment's distance for X, Y, and Z? So let's start with X here. We're not given what X is, but we know how fast it's moving per second. So can we use this to figure out how far he's going to be 3 seconds after the timer starts, after he passes out from under the balloon? Yeah, we don't have the X yet, but we do know how fast he's going, and we know for how long. No, we can find it. If you're traveling at 17 feet per second, and then 3 seconds passes, that means it's 17 feet, 17 feet, 17 feet, right? So 17 times 3. Does that make sense? All right, so 17 times 3 gives us 51.
Now we can do
Yeah, so something about the Y though. So the balloon is 65 feet when the bicycle passes out from under it. But 3 seconds later, is the balloon still going to be 65 feet above ground?
you get times it by you get to add 51 to it.
Now 51. 51 is for the bicycle. How fast is the balloon moving? 1 foot per second. So if he's here at time t equals 0, where is he going to be at time t equals 3? 68, right? So at 0 seconds, he's at 65 feet, but then 3 seconds later, he's going to still rise at 1 feet per second. So plus 3, it's a little tricky there, 68. Let's remember that balloon is still moving, even though they told us that's 65 feet to begin with. Now we can do what? Pythagorean theorem, right? A squared plus b squared equals c squared. We find that z value, and then everything is ready for you to solve for dz/dt. Okay, so try that. You can use your calculator and then
So do you solve it when we before in town? That your theorem, do you when square plus y squared is squared, or you do when 2x
well, yeah, the Pythagorean theorem, you're going to use the original one.
Okay.
To find z, but then once you find z, then this everything else can just go ahead and do it. Okay, your derivative equation. All right, any questions with number one? All right, once you gather all the information, then the rest is plugging in, right? This should hopefully feel pretty straightforward once you have this filled in.
Also, can only be two of those.
Huh?
Can only be two coming.
Right, yeah, so,
They'll never be on their own. They'll be part of like a problem. It's problem.
um, depends, yeah, the area of a triangle may be connected to something else. Maybe connected to the magnitude. Okay, so any questions with one? Okay, number two, let's do a linear approximation one. Remember, a linear approximation is where you focus on building your tangent line equation. Don't even worry about the decimal. Find your order pair, find your slope, point slope form. And then once you have that taken care of, then you can worry about the decimal and plugging that in for x. Okay, so let's just focus on writing the equation of tangent line. So we need to find the order pair. I have x equals 2. So how can I find order pair?
That of two, that's we.
Yep, into the original equation. Yep. Okay, what's next?
0.
Let's see. We want to find the equation of tangent line. So we have order pair. What else do we need to find?
Slope.
Slope. Yeah. So slope, we first have to find the
Or
derivative, right? Yeah. So find f prime, find f prime of 2. Okay, try that.
you don't need like any DXCT or anything like that for these ones. Right?
Nope. No. Yeah. We don't have to do that for linear approximation. Okay. Do we have enough to build our tangent line equation? Yeah. You got your order pair. You got your slope. Point slope form. I'm just going to move that 8 over just to get that y by itself to kind of get it ready for what I'm about to do next with the decimal. Right, so there's your tangent line equation. What's the final step here?
Put a 1.9.
In for the x, right? Yeah. Okay, any questions with A? Right, part B is the same thing for the most part, but what makes it a little easier here?
It gives you already the point in
Yeah. So you have to put in the point slope form and plug in the 5.2, right? Okay, try that. Should go a little faster. It already give you everything you need. Okay, order pair 5, 3, slope is -2, point slope form. I'll just move that 3 over to the right and then plug in the 5.2.
So H prime method. Oh, so you move over the.
Well, h prime of 5 equals -2. That's my slope. Yeah, my order pair is 5, 3. So once I have this in front of me, then I'm just going to use that.
We haven't worked on one of these in a while.
Yeah, that's right. Yeah, so this is the first thing that we covered, and then we jumped to related rates after that. But any questions with these type of problems?
And for the next one, for the limits, like we have to use the L'Hopital's pros.
Yes, I want you to show me L'Hopital's rule. Okay, so let's look at number 3. Okay, what's the first thing that we always do, regardless of things?
Substitution.
Yeah, direct substitution, right? We don't want to jump to L'Hopital's rule until we get something that tells us that we can use it, right? You have to show that there's indeterminate form before you do L'Hopital's rule. So that means either 0 over 0 or infinity over infinity. And you're going to use L'Hopital's rule more often for 0 over 0 than infinity over infinity. Okay, so 3 goes in for x. What do we get?
Not 0, 0.
It's not, right? So whatever, if we get a number, then that should be our answer, right?
Minus 26 on the bottom.
Or -26.
And 21's on the top. That's your answer. So
That's your answer, yeah. If you want to reduce, you can, but oh no, that's all right. We can't reduce. This is far. All right, so no L'Hopital's rule here, right? Even though you may feel like, oh, I want to find the derivative, but there's no need to, right? And if you find the derivative and reevaluate, you're gonna get a different answer. It's no longer the correct answer. It's only going to work if you get 0 over 0. So that's our limit. There's no need for L'Hopital's here. Okay, part B. Direct substitution. This one does give you 0 over 0, so we can do L'Hopital's rule once. Okay, what's the derivative of the numerator?
20x third minus 8x and 0. That's it.
Yeah, good. Okay. Denominator?
And then 0 and -1 and -1 first, and then minus 27 squared.
X squared, yeah.
Could you put the x squared like in front of -1, or do you keep it?
You can. I just like to, yeah, it's up to you. Yeah, whatever. The order is not going to matter. Okay, so plug 1 in for x. Direct substitution now. If you don't reduce your fraction, that's okay, but you have your calculator, so it's not too bad. Okay, any questions with 3? Okay, number 4, we have a cylinder problem here. Okay, water's leaking out of a cylindrical container. at a rate of 5 cubic centimeters per hour. The container has a diameter of 12 centimeters. Sorry, diameter of 12 centimeters. A height of 16. Okay, here's my volume formula. Let's gather information from this problem here. Water is leaking out of a container at a rate of 5 cubic centimeters per hour. Dt. Positive or negative? Because
It's like decreasing.
leaking out, which means the water inside the container is decreasing, right? At what rate is the height changing? When the water level has a height of 3 centimeters.
You don't use H equals 3 till the end.
I'm sorry?
You don't use the H equals 3 till the end, right?
Mm-hmm. That's right. So,
What the radius would be 6 centimeters.
do we have to involve similar triangles with this?
No.
No similar triangles. So, what do you know about the radius? It's not changing. So I can just replace it and just build my volume equation from there. So V equals pi times 6 squared times H, right? It should feel like an easier problem than cones. Okay, so I can find my derivative, right? There's nothing that's preventing me from moving forward here. V becomes equals. Good. All right. Do we have enough to solve for our missing variable? Yes. That -5 for dV/dt. Solve for dH/dt by doing what?
Bring everything over
Divide by,
36 pi.
where's the pi located? Denominator. It needs to stay there. It needs to stay there. Yeah. What's our unit of measure? Centimeters per hour, right?
There's no squared or cubed.
That's right. No square, no cube. We're talking about height here. The only time you're going to see squared or cubed is with volume or area. Now, let me point something out here. What information do we not even use in this problem?
The height.
Of the water level and the height of the cylinder.
Diameter.
Well, we did use the diameter to get to the radius, right? But why do you think this problem has this information even though we don't use it?
Distractors.
Yes, it's distractors, right? It's like, are you going to fall for that? Are you going to treat this like a cone problem and do this? R over 16 equals H, sorry, R over 6 equals H over 16, right? This doesn't fit this problem, right? So yeah, just beware. On cylinders, there are going to be some distractors. to see if you will fall for that. Are you gonna treat it like a cone, or are you gonna know to move forward and replace that radius?
So you only do it for what's it, cone problems, right?
That's right. We only do this special relationship for cone problems. And also, well, I mean, we do have a similar triangle relationship for shadow problems, but that's a lot easier, right? That you just build the relationship, and that is your equation. With similar with cone problems, this relationship is so that we can put into do substitution into the volume equation. Okay. Next up. We'll come back. Let's come back to number 6. Number 6 is another Pythagorean theorem problem with the area attached to it. I want to get as much practice with cones as possible. So let's try number 7.
So you recommend like rewriting the volume, like even though it gives it to you, you recommend like rewriting it in your own writings.
Oh, yeah, it's up to you. I like it. It just feels like it's less pieces. Okay, everybody good with creating the proportion equation here? Okay, everybody good identifying what's given to us in the problem? The dV/dt is negative, h is 30, dH/dt is the unknown. Do we touch this 30? Not until the end, right? So just save until the end. Okay, how does dH/dt help us decide how we should set up our volume equation?
In terms of h,
In terms of h, so we want to remove what?
r squared.
R, yes. Well, the pi is fine. That's the r squared, the r that needs to be replaced. So if I want to replace r, I should solve for r, right? So what's r equal to?
30h divided by 40.
Is there a cleaner version of that?
Yes, 3h divided by 40.
So here's my substitution step. Everything is in terms of h. Am I ready for my derivative? Not yet. You could, but you got to go through product and chain, but that's not what students do. Students want to just do power rule, but it's definitely not ready for power rule.
You over chain rule too?
We could do chain rule, but we don't want to, right? It's too much trouble, right? Why not just clean it up and just do power rule, right? So how do we clean this up? Yeah, let's square what's inside the parentheses. Let's put all the fractional values together. Let's merge all the h's together. Okay. Still not ready for power rule, okay? Still not ready. If I push all the fractional coefficients together, what is that?
NH cubed.
What if I separated these two things? What about just the fractional numbers? 9 pi over 48. Then if I merge the h's together, I get h cubed. This is where we want to be before we do the derivative. You try to find the derivative before this, the chances are it's going to be easier to make a mistake. So we want to get to this point before we do anything with derivative. Okay, so from here, it should be hopefully more straightforward here. V becomes ddt. Coefficient stays. H cubed becomes 3h squared. Dht. Okay, do we have dvdt? Do we have h? Yeah, and we're looking for dht. So everything that we need is ready for us to use, right?
Can you play the height now?
Yep, now I can put in a height, yep. Once that derivative shows up, the height is now ready for us to use.
I mean, you must have a reciprocal.
Reciprocal, yeah.
-96 over -96 over.
Yeah, let me try that again. I messed up somewhere here.
Because it's not 100, so it's 2000 or 24. I didn't get the 81.
100 over 16. Sorry, it's over 16. 48. Let me try it again. This is my key here. Let me see what I did on my end.
Oh, you can simplify 9 and 48.
Yeah, let's see. Sorry, I messed up. Wait, 3.
Maybe it was one of like we're solving the volume.
Yeah, this answer is right. I think I just, when I was working it through, I think I lost a number somewhere in between, but I'll go off of this one here. Here, 5 versus. So 9/48 is the same thing as 3/16, right? Now, do you guys get this answer as well? You did, okay. So I think I multiplied wrong somewhere along my way, but I know this is. So this one, I reduced that 9/48 to be 3/16. I went through power rule, replaced the h with 30, multiplied, reduced, multiplied by the reciprocal, and keep track of that pi in the denominator. Okay, we'll do more problems on Monday. I really encourage you guys to do problems over the weekend. But here's an idea of what the quiz will look like. Just you'll get a phone problem, a linear approximation, a what we call Pythagorean theorem, and then I'll choose 2 from these. Could be a volume surface area, a shadow, a cylinder, area of a triangle, area of a circle. Now send out a text reminder about that. Monday, yeah, come get your phones. Monday, review, help session, Monday morning, Monday afternoon, and Tuesday morning.
This right here. Is that a test?
That's the name of the section. It's called
Oh.
first derivative test.
Oh.
Yeah.
Are you ready for this, please? How's it work? What did they ask you? The basics of caution. They like a weird report. Yeah, they barely asked. Also, okay. But like this, it's not. Yeah, I know it was there. Yeah, it's for sure. Figure if you have to, because like, I'm like, why is everybody taking a picture of me?
Well, is there any way I can go to my account? So I just.
Maybe see, have a good weekend.
Probably go to it.